In this video lecture, we are going to study lossless join decomposition. And the short learning plan is that we are going to formally define what we mean by lossless join decomposition, and we are going to see what is the condition for a lossless join decomposition. Let's remember what we mean by decomposition by looking at this STU4 relation with three attributes and just one functional dependency. SID determines the name. Let's decompose this into two relations where the first relation has SID and the name. So we take the original relation and project it on SID and the name to come up with the first relation R1. And the second relation just has SID and phone, and we obtain this relation R2 by projecting the original relation on attributes SID and phone. So the first relation will have the functional dependency SID and the name because it has SID and name attributes, while the second relation will not have any functional dependencies. Now let's try to join these two relations with natural join. Let's see what we are going to obtain. Remember that when we are doing natural join on the common attribute, we match two rows from the two relations which with the common SID in this case. And the resulting relation will be the same as the original relation. So in this case, the original relation was obtained. And but we have seen the cases where the original relation cannot be obtained. So what is the general rule for lossless join? That's the question that we would like to answer in this lecture. In general, given a relation R with attributes X, we can always decompose this relation into two relations such that the first relation R1, let's say, has attributes X1 and R2 has attributes X2. Okay? And we need to make sure that the decomposed relations schema, when they are combined with the union operator, will always give us the schema of the original relation. So that's the first thing that we need to be very careful about. For example, if we have a relation R with four attributes, we can decompose it, for example, into two relations R1 and R2, with R1 having three attributes, R2 having three attributes, and when we take the union of the schema of R1 and R2, we'll have the original schema. So that's the first thing. In general, for a decomposition to be a lossless join decomposition, for all instances of the original relation, when we decompose that instance and when we join using natural join, we should always obtain the original instance. More formally, if we have a relation R with attributes X, and let's say we decompose it into R1 and R2, R1 has attributes X1 and R2 has attributes X2. First of all, the union of X1 and X2 should be equal to X, the original schema. And for this decomposition to be lossless join decomposition, for all instances of R, let's say one of them is denoted by lowercase r, for all instances of R, the projection of R into X1 and projection of R into X2, when we take the natural join of these projections, we should always obtain the original relation instance R. If this is the case, then we say that this is a lossless join decomposition. But this should be true for all instances, all possible instances of R. And in general, when we do such decompositions, when we decompose R into R1 and R2, such that the union of the schema is equal to the schema of the original relation, and of course the intersection of the schema should be non-empty set, such that we can do a natural join. And when we do a natural join based on an instance of R, denoted by lowercase r. In general, the natural join will be either equal to the original instance or it will have more attributes, more rows. But we would like the natural joins to be always equal to the original relation instance. If this is so, we have lossless join decomposition. And the if and only if condition for lossless join is that when we have a relation R with functional dependencies f and attributes x, let's say that we decompose this relation into R1 and R2, again such that the union is equal to x. This decomposition is a lossless join if and only if the intersection of the schema of the sub relations should either be a key in R1 or they should be a key in R2. So basically, after the decomposition, for the decomposition to be lossless join, the intersection of the sub-relations should either determine the attributes in x1 or the attributes in x2. These functional dependencies, one of them should be implied by f. Here's an example. Let's say we have R, a relation with functional dependencies, let's say f. This can be decomposed into A, B, C, and B, C, D, like we have seen before. But for this decomposition to be lossless join decomposition, the intersection of A, B, C and B, C, D, which is B, C, should be either a key in R1 or should be a key in R2. So key meaning that for BC to be a key, it should determine itself and the rest of the attributes, A in this case, or in the other relation, D. So if either of these functional dependencies is implied by F, then we have a lossless join decomposition. Let's look at a more specific example. The person table with one functional dependency, SSN determines the name and the address. Let's decompose this relation into two relations, where the first relation has SSN, name and the address, and the functional dependency, SSN determines the name and address, will correspond to this relation, R1, because the attributes SSN, name and address are in this relation. And let's say for the second relation, we just have SSN and hobby, and there is no functional dependency that relates SSN and hobby. Is this a lossless join decomposition? To understand this, we need to look at the intersection of the schema of the relations that we decomposed. What is the intersection? It's SSN. So SSN should be a key either in R1 or R2. In R2, it's not a key. There's no functional dependency. SSN doesn't determine the hobby. But in R1, SSN determines the name and address, the whole relation. So that's why it's a key in R1. So I can say that this decomposition is lossless join decomposition. Now let's decompose this same relation into other two relations. Let's call them again R1 and R2, but this time the first relation will have SSN, name and hobby. Instead of the address, we just include hobby. And the second relation will have the name and the address. Now, you see that we have SSN determining the name and the address. So remember from the topic of functional dependencies, when we have a functional dependency like A determines BC, this is equivalent to A determines B and A determines C. So we can decompose this functional dependency into two functional dependencies. So for the case of SSN determines the name and the address, we'll have two functional dependencies. SSN determines the name and SSN determines the address. So SSN determines the name is projected into F1 because we have SSN and name here, but not the address. And in the second relation, we don't have any functional dependencies relating name and the address. And we cannot include the functional dependency SSN determines address in any of the relations because SSN is in R1 and address is in R2. So we cannot have a functional dependency that's across two relations after the decomposition. So this dependency is lost. Now, let's do a natural join of the decomposed relations R1 and R2. We see that after the natural join, we were able to obtain the original relation for this particular instance. So we got the original table. But does that mean that this decomposition is lossless join decomposition? No, because for decomposition to be lossless join decomposition, this phenomena should happen for all the instances, all possible instances. Let's look at this particular instance and let's decompose this into again SSN name hobby and name address relations. Again, the functional dependencies are projected. Now, when we join these two relations with natural join on the name, remember the natural join, we take two rows from the two tables. We look at all the rows, and we include the rows with a matching name in the resulting relation. And you see that there are lots of rows actually that are introduced due to the natural join. So the resulting relation is not equal to the original relation. So we have seen that just looking at just one instance does not tell us that the decomposition is lossless join decomposition, and we should apply the general rule that the intersection of the schema of the subrelations should be a key in either of the relations. And in this case, when we decomposed, when we look at the intersection of the schema of the subrelations, the intersection is name, and name is not a key in either R1 or R2. So this is definitely not a lossless join decomposition. Here's a summary. We have seen lossless join decomposition again, and we have seen that joining the resulting relations does not tell everything about lossless joins. In one instance, after decomposition and rejoining, we can obtain the original relation, but we should have this property for all instances. And checking all the instances is not possible, but we have an if and only if condition for lossless join decomposition that the intersection of the schema should be a key in either relation. So that's the end of this lecture.